Genesis and the Big Bang. A presentation written and narrated by Chuck Missler.
Tonight I thought we'd like to explore a little bit the nature of light and how it appears in the Scripture, and some interesting things that have been recently discovered that shed new light on light. We might just pick up from Genesis chapter 1. Use that as our springboard tonight. Genesis chapter 1. Bereshit bara Elohim. In the beginning, God created the heaven and the earth. And in the Hebrew, after the word Elohim, there are two little letters, an alpha and a tau, untranslated, because it's not connected to the word, and therefore it's not used prepositionally. It's just there. It's an et. But if I read it in the Greek and said, in the beginning, God, the Alpha and the Omega, created the heaven and the earth, what would I mean? Jesus Christ. What's in Hebrew? In the beginning, God, the Aleph and the Tau, created the heaven and the earth. That same kind of phenomenon occurs several times in Genesis, but it also occurs in Zechariah, chapter 12, verse 10. Zechariah 12:10. It's again in the Old Testament, 500 years or more before Christ was born. Zechariah wrote, God says, I will pour upon the house of David, upon the inhabitants of Jerusalem, the spirit of grace and of supplications. And then this famous phrase, and they shall look upon me whom they have pierced. Interesting passage for the Old Testament. The day will come when Israel will, in fact, look upon me whom they've pierced. Pierced? Yes, as Psalm 22 describes the crucifixion. It's an Old Testament prophecy of the second coming of Jesus Christ. What's interesting about it, though, if you take a Hebrew interlinear, that is a Hebrew Bible where the Hebrew, and then under the Hebrew you've got the English words. The English words, of course, will be in a different order. It'll be in the Hebrew order, in other words. But the point is, it's a way of looking at the translation. You'll notice on that page, every Hebrew word has one or more English words under it. Except one. There's a strange thing right after the word, they shall look upon me. There are two little letters, an aleph and a tau. And what it really says, in effect, is, and they shall look upon me, the aleph and the tau, whom they pierced. In Greek, it'd be alpha and omega. In Hebrew, it's the aleph and the tau. In the English, it'd be the A and the Z. The beginning and the ending, the first and the last. The Ichyach Asher Ichyach, the I am that I am. The ego I me. Any case, so we know who we're talking about. And by the way, in Genesis chapter 1, if that still isn't clear, read the first 3 verses of the Gospel of John, where he uses the title of the Word of God as the title of Jesus Christ. But moving on, in the beginning God created the heaven and the earth. But the earth became without form and void, or ruined and uninhabited in the Aramaic. And of course that leads to a speculation called the gap theory, which is provocative but usually misapplied. But darkness was upon the face of the deep, or the abuso. So whatever the occasion, whether it was a previous judgment, as some speculators suggest from the language, and that's very defendable, or whatever, in any case, that's the starting point of the narrative here. Then we come to this interesting phrase, and the Spirit of God vibrated, brooded on the face of the waters. The Ruach Elohim, the only place in Genesis that particular phrase is used. You want to study the Holy Spirit, you don't start in the 2nd chapter of Acts, you start in the 2nd verse of the book of Genesis. Here's where it starts. The Spirit of God moved. The word is the same word that would be used of a hen brooding over her eggs. The Spirit of God brooded over the face of the waters. The word means vibrate. And after our excursion on superstrings and the latest insights of particle physicists and so forth, I think that's fascinating for lots of reasons. And some of the things I'll be touching on, if they provoke a curiosity, I encourage you to, we have a trilogy of briefing packages, Beyond Time and Space, which attempts to explore Einstein's theory of relativity and its implications biblically. And we'll touch on some of that tonight. Beyond Coincidence, which is evidences of the universe being designed, and then also Beyond Perception, which attempts to explore the insights that we've gotten from particle physics in the Bible. And some of those things, if these are provocative, you'll find expanded on there. But the Spirit, the Ruach Elohim, vibrator moved upon the face of the waters. Now, when you say waters, don't assume that what's in view is H2O, or water, aqua. Most of us, when we were in school, learned there were 3 states of matter: solid, liquid, and gas. Wrong, there's 4. The 4th one usually don't get into until you're in college. Solid, liquid, gas, and plasma. Conditions in which matter isn't in atoms. The atoms are stripped, if you will, of their integrity. And we have ions. There are ion engines in space travel, plasma engines. There's conditions into which matter gets into what's sometimes called the 4th state. Some people who analyze Genesis from a physics point of view suspect that what may be in view here is the 4th state of matter. But that's all a conjecture, and I don't want to get into all that here. I'm really heading for verse 3. It's the first quote of God in the Bible. There are 10 of these in Genesis chapter 1. Because there are 10 quotes in Genesis chapter 1, an ancient Hebrew sage by the name of Nachmanides concluded that the universe has 4 dimensions, 4 are knowable and 6 are not. Now, it's not quite that simple, but that's basically where he came to that conclusion, is from the analysis of the Hebrew text involving those 10 quotations of God. Now, what makes that interesting is that he concluded that, from Genesis 1, that the universe has 10 dimensions, 4 are knowable, and 6 are unknowable in his terms, as a Kabbalist. And of course, if you've studied the writings of modern physics today, you know that the most advanced thinking in particle physics and what have you is that the universe, they now believe, has at least 10 dimensions. 4 are measurable, length, width, height, and time. 6 are curled in less than 10 to the minus 33 centimeters, and therefore inferable only by indirect means. I think that's very interesting. The heterotic strings cost us billions of dollars of experimental equipment, and we could have just found the same thing out by reading Nachmanides, who wrote 800 years ago. But anyway, and of course I'm only being a little flippant here. Anyway, the first quote of God in the Bible, and God said, "Let there be light." Or more precisely what he said is, "Let light be." He called it into existence. Let light be, and there was light. This leads us into the discussion of light because, first of all, it's interesting, of all of science, we seem to know least about light. It's one of the most puzzling aspects of physics. And yet we notice that the velocity of light, a parameter usually designated by the lowercase c, is everywhere in physics. You've all encountered this E equals mc squared. It's usually an equation symptomatic of Dr. Albert Einstein. E equals mc squared. Matter and energy are interchangeable in a sense. You can convert mass to energy. That's what a nuclear warhead is all about. E is the amount of energy, mass is the mass, and c is the speed of light, and it's c squared. E equals mc squared. A little bit of mass, if released into energy, unleashes an enormous amount of energy. This, in effect, involves the first law of thermodynamics, that energy and mass are equivalent, can neither be created nor destroyed. In other words, it'll always balance. There's no way to create mass or energy. You can transfer one into the other, but you can't create it from nothing. God can, we can't. It's interesting, if we bother to get in some other equations, if you study mass in terms of being accelerated, it turns out the mass that's been accelerated is equal to the mass at rest times a parameter. It's 1 over 1 minus some squares. It's velocity squared over its speed of light squared. It turns out that very, very quickly, as you start accelerating, the mass starts to increase. To get the mass at the speed of light would require an infinite amount of energy. So again, we discover that as things get relative, even physical things like mass, we find the relationship to other mass, in terms of their velocities, all tangled up for some reason in the speed of light. The limits of our universe, our observable universe, are described by Minkowski diagrams. They're all based on the idea. All of our concepts in physics are based on the idea that the speed of light is a constant. There's actually the 3 laws of thermodynamics. The first law is matter or energy can't be created or destroyed, which another one says, the first law is that you can't win. Second law of thermodynamics says that there's always a loss. Whenever you make a conversion, there's always something lost in ambient heat. That somebody's paraphrased that by saying that says that you not only can't win, you can't break even. The third law of thermodynamics has to do with entropy. It says you can't get out of the game, but we'll get into that a little bit later. One of the things I'd like to do is put in perspective this concept of the speed of light, because the ancients, such as the early Greek philosophers like Aristotle, they took for granted that light was instantaneous. It's understandable. When you turn on the light, it's on immediately. As we experience light, it's natural for us to take for granted that it travels at an infinite speed, or putting another way, it's instantaneous. And you can go through the ancients all the way through. There's a couple of exceptions, but I'll spare you for tonight. They all believed in an infinite speed of light. Roger Bacon, Francis Bacon, in 1600 AD, both believed in the finite speed of light, but they weren't taken seriously. But it was about 1600 AD that Johannes Kepler, the father of modern astronomy, Kepler's laws are the laws that summarize the movements of the planets. He even maintained the majority view, which was that light was instantaneous. This is a sophisticated astronomer of the time in the 1600s. René Descartes, the highly influential scientist, mathematician, philosopher, he died about 1650. He also strongly held to the instantaneous speed of light. So with these kinds of people, you need to understand that was the accepted understanding. But in 1677, a Danish astronomer by the name of Olaf Romer, he noticed that the eclipses of Jupiter, Io is one of its satellites, that when Io eclipsed Jupiter, time it would take would be different depending on where we were in our orbit. If we were closer or further, there was a 15-minute difference. And he began to conjecture that possibly that was an indication that it took took longer to get to the Earth. So he started to analyze that, and he discovered he could account for that difference if he assumed a finite speed of light, and he thus measured that speed of light. He came to the conclusion that the speed of light was about 307,600 kilometers per second, give or take 5,000. It took 55 years for the physicists to swallow that. He published these results. They were there for analysis. But the physicists just couldn't buy that. They took for granted that everybody knows the speed of light is instantaneous. It took 55 years till finally a British astronomer in 1729, James Bradley, he did an independent confirmation using the same approach that Romer did, and that finally ended the controversy. So it isn't until 1729 that the physics world finally recognizes that the speed of light is not instantaneous. It travels at a finite speed. Now, the reason I'm getting into this is the speed of light has been, over the last 300 years, has been measured 163 times by 16 different methods. And I won't take you through the 163 measurements, so you can relax. As a Naval Academy graduate, I have to include Albert Michelson. Many of you may have, he was technically German-born, became over at the age of 2, but he is the Naval Academy class of 1873. And if you visit the Naval Academy, you can see the places where they've marked out where he did his famous experiment. In fact, he's the first American to get the Nobel Prize in Physics for his works of various kinds in 1907. But he first measured the speed of light in 1881. He also measured it again in 1923, and he measured again in 1933. And I'll come back to that because I took the trouble, since I put these notes together, do a little digging, and I found out that if he'd been paying a little bit more attention, he might have discovered something that has now made a lot of rumbles in the field of physics. Because what's happened in the recent years, there's an Australian physicist by the name of Barry Setterfield, and his sidekick, Trevor Norman, mathematician. They got interested in this for a number of reasons. There's a number of paradoxes in the field of cosmology. And I won't bother taking you through those because they're very technical, of a very specialized nature, but they're very, very serious paradoxes that they confront in the field of cosmology. And he was wrestling with these, and they were paradoxes only if you assume the speed of light is constant, which caused him to investigate more seriously the possibility that maybe the speed of light isn't constant. And Barry Setterfield and Trevor Norman tracked down, collected, compiled, pulled together all the raw data they could find from these ancient experiments. And they analyzed them on a computer. And they discovered some interesting things. Romer's experiment in 1657 concluded the speed of light was 307,600 kilometers per second with an error of plus or minus 5,400 kilometers per second. Not bad for a guy in 1657. Harvard University in 1875, using the same technique, that is by precise observations of the eclipse of Io, one of the satellites of Jupiter, concluded it was 299,921 plus or minus 13 kilometers per second. Now, obviously, with the improved technology, they brought the error of much smaller band. Instead of plus or minus 5,000 kilometers, it's now plus or minus 13 kilometers. But there's something rather strange, if you look at that figure, is because the mean isn't even in the range of Romer's experiment. Well, maybe he just had a larger error than we really realize. National Bureau of Standards, 1983, using laser techniques, concluded that it's 299,792.4586 plus or minus 0.0003 kilometers per second. Precision is much tighter. But wait a second. That's outside the band of error of Harvard. Because if you take the 291,921, subtract 13, take it as small as possible, you're still larger by over 100 kilometers per second. Do you notice what's happening here? It seems to be slowing down. I couldn't resist. I checked into Albert Michelson, my classmate, my academy, not a classmate. I'm no old, but not quite that old. I feel that old sometimes. His number in 1881 is 299,853. In 1923, 299,798. In 1933, 299,774. It intrigues me that even within the range of his own experimental error, the mean is declining. Barry Setterfield, by the way, this is about, for those of you who may have learned it different, 186,000 miles per second. Pretty fast. About a foot per nanosecond. In other words, in 1/1000th of a second, light travels about a foot. It goes a foot per nanosecond. One reason you try to make computers small isn't for convenience, it's for speed. Because computers very quickly became limited by the distance electrons had to travel within the circuitry. So one reason these chips are so fast is because they're so small. Not the only reason, obviously, but it's a major, major aspect. Those of you that are keeping track of this sort of thing might want to know that a dynamical second is defined as 1/31,556,925.9747 of the Earth's orbital period. I thought you'd like to know that. And it was a standard until 1967. Atomic time is defined in terms of one revolution of an electron in the ground state orbit of a hydrogen atom, for those of you that really want to be precise about this sort of thing. Well, as you can imagine, when Barry Setterfield and Trevor Norman published these findings, the physics world laughed at them. These guys are nuts, you know. I mean, to this day, you'll find most classical physicists do not take Barry Setterfield, Trevor Norman very seriously. What I'm sharing with you is something that is very controversial in the field of physics. And I'm sharing it with you as a matter of awareness, but also to stretch your horizons a little bit. Each year that goes by, every time I look at this, every time I look at another technical journal, I discover here and there another notable scientist is beginning to take Barry Setterfield and Trevor Norman's hypothesis seriously. Alan Montgomery, a well-known Canadian mathematician, took their data, it turns out to be a very complex statistical analysis on a computer, put it on a computer, and he concluded that not only is the speed of light, the decay of C as they call it, not only is light slowing down, but it's following a very specific mathematical curve to a 99% correlation factor. It's a cosecant squared curve, for whatever reason. Now, what makes it difficult is that it's almost asymptotic in the current period. In other words, since about 1958, the differences are infinitesimal. But the previous data implies that in the past, it had been going faster. The further back you look, the faster it was going. In fact, the curve, the cosecant squared curve, if that is an accurate curve, that would imply that in the time of Christ, the speed of light was about somewhere between 10 to 33% faster than it is today. It would have been in the days of Solomon about twice as fast as today. In the days of Abraham, about 4 times as fast as today. This would imply that the velocity of light could easily have been more than 10 million times faster as you get to 3000 BC or earlier, just to give you a rough feeling for it. The implications of this, if correct, are staggering, and they totally alter our perceptions of the universe. Now, by the way, Barry Setterfield reports that there's confirming trends in 475 measurements of 11 different other atomic quantities by 25 different methods. So there are atomic measurements that seem to support this. And I'll come to some other interesting examples shortly. Now, in some PhD programs at some of the universities, one of the exercises they give a PhD candidate in physics is an exercise to think through the implications of what does a change of speed of light imply elsewhere in terms of atomic behavior. See, the speed of light shows up everywhere in equations. And if the speed of light is changing, it alters all kinds of other things. And they don't do this, they don't give him this exercise because they think it's changing. They give it as an exercise so that he can demonstrate his understanding of the interrelationships. There's 2 properties of space known as magnetic permeability and electric permittivity. Their product is the reciprocal of c squared. Permittivity of free space doesn't seem to have been changed, but the permeability has. And this is related to the stretching of space. One of the things you and I don't think of these terms, mathematicians do. They speak of the stretching of space. It's fascinating to read these papers about the stretching of space, because as you read those papers, you can't resist turning to Isaiah chapter 40, which we will. Isaiah chapter 40, verse 22. It is he, speaking of God, it is he who sitteth upon the circle or the sphere of the earth. How many of you knew the earth was round? It's a wonderful painting. I'm going to have to get my hands on one. I see it in some offices now and then. It shows this galleon at the edge of the earth, and the water's, the ocean is flowing, and the galleon, they're struggling, trying to keep it from going over the edge. The caption says, "I told you so," Is he that sitteth on the circle of the sphere of the earth. The inhabitants thereof are like grasshoppers, speaking of God again, who stretches out the heavens like a curtain, who spreadeth them out like a tent to dwell in. Many people reading this would assume it's just figurative language. It's perfectly permissible. But let's go to, and by the way, in verse 26, as long as we're here, I can't resist pointing out that this is where it also points out that God calls all the stars by name. Let me tell you, gang, that's a lot of names. The Milky Way alone has 100,000 million. If you named one of those every second, it would take you continuously take you 2,500 years. That's just the Milky Way. And there's billions of galaxies, much larger. Anyway, but let's go on to Isaiah 42. Verse 5, thus saith God, the Lord, who created the heavens and stretcheth them out. Strange idea. How do you stretch out the heavens? Who spread forth the earth, and so on it goes. 45, verse 12, I have made the earth and created man upon it. I, even my hands, have stretched out the heavens, and all their host have I commanded. And 51:13, Jeremiah 10:12, Jeremiah 51:15, and on it goes. We hear there are passages which speak of the heavens as a scroll. Even Revelation speaks of that. Revelation 6:14. As you hear those terms and you read them in the Bible, you tend to regard them as figures of speech, as idioms, and maybe indeed that's all they are. And yet it's interesting, as we begin to understand space, scientists speak of the curvature of space. They speak of it being stretched. They speak of it being relaxed. Now, the relaxation of space turns out to be mathematically equivalent to the introduction of entropy. Now, and I want to talk a little bit more about entropy before we're through here. It turns out, mathematically, the shrinkage of space, the introduction of entropy, is equivalent to the slowing down of the speed of light. So one of the things that suggests itself, and now I'm going to share some things that I don't think necessarily Barry Setterfield argues, because Barry Setterfield has a slightly different view, but there's several of us from what we know so far, that suspect the speed of light. First of all, we know mathematically the speed of light is associated with the increase of entropy. Entropy is the decay in the universe. The entire universe is going towards randomness. That's what entropy means. It's a mathematical equivalent to randomness. We'll talk a little bit more about that in a minute. But I want to first of all link the introduction of entropy to Genesis chapter 3. In Genesis chapter 3, Adam, who up till then was perfect, clothed with light, sinless, walked with God. You and I have no capacity to even imagine that, because we only know Adam in his fallen state. We only know the creation post-curse. We know very little about the creation prior to Genesis 3. A very, very abbreviated summary in the first 2 chapters of the book of Genesis, and a few hints from Isaiah and Job and some of the Psalms. Only glimpses. We think and interpret the creation in terms of its state after the curse that's pronounced in Genesis chapter 3, verse 15, when God declares war on the Nachash, the shining one, the one that caused Adam to fall. We discovered by examining Isaiah 14 and Ezekiel 28, we discover the origin, the beginning of the career of one of the 5 cherubim that we know of in the Scripture. 4 we know guard the throne of God. There's a 5th that at one time was numero uno. But through pride, Isaiah tells us in chapter 14, he fell because he wanted to be like the Most High. Didn't say he wanted to be the Most High. He wanted to be like the Most High. There's an interesting subtlety there. It's interesting that God created Adam in the likeness of God, whatever that, in the image of God, whatever that means. I don't want to get into all that here. But one conjecture is that created a rival, and in pride, Satan resolved to bring him down. In so doing, Satan fell. He may have fallen prior by some other acts for all we know. But clearly, the fall of Adam, engineered by Satan in Genesis 3, introduces the curse. God declares war on the Nachash, the shining one who becomes the serpent and so forth. And therein lies the curse. In Romans 8, we find that the whole creation groans and travails for the manifestation of the sons of God. That this curse is far more than just Adam personally. The whole creation has to endure that curse because it's somehow all tied up with Adam's own dimensionality and what have you. It's my personal suspicion or conjecture that it's at that point that entropy is introduced, and it's probably at that point the speed of light starts its journey slowing down. The slowing down of the speed of light affects everything. It affects atomic behavior. It affects molecular behavior. It very well may be the hidden explanation for the long longevities in those early chapters of Genesis that puzzle us from our day reading about people living 969 years. We can't visualize that. And yet the mystery of aging is a big mystery. If our body continually replenishes itself, why do we age at all? They conjecture it has something to do with cosmic rays and introduction of error in the process, possibly. But in any case, the mystery of aging is something that a lot of research is being done to understand why do we age at all. If our bodies are self-repairing and self-perpetuating, why do we age? All different kinds of tissues replenish themselves at different rates, but I think the numbers are that every 7 years or so you got everything new. Well, that's great. And yet, it's not quite that way, is it? So there's something else behind it all. There's the red shift of the stars. The astronomers in the 20s discovered that the stars, as they used spectrograms, and they discovered that stars can be analyzed in their composition by the spectrogram of the light. But all the light seems shifted slightly to the red. Different amounts for different stars. And Edwin Hubble, the guy after whom the space telescope is named, formulated what's called Hubble's law, that the light, the amount of red shift correlates with the distance from us. That implies that the universe is expanding, that they're all rushing away from us, and the degree to which they're rushing away is a function of their distance from us in the first place. Hubble's law. But it turns out the redshift can also be explained simply by the universe contracting, not expanding. That's one theory that's also very controversial. But there's even something else that's recently been discovered. See, I'm really going to highlight the field of physics, which incidentally has been our most solid of all the sciences. All the sciences have their problems. But the field of physics has been perhaps the most solid, orderly field of science throughout history. And one reason is because they've got auditors. The theoretical physicists do the mathematics, the experimental physicists validate it. So all the way along, you've got a check and balance procedure in the scientific method. The other fields of science do not have that advantage. Well, it's interesting that the most solid of all the fields of science is in major turmoil today. Some other things going on. Because of the red shift, scientists have assumed that the universe is expanding because all these stars are rushing away from us. And because the universe is apparently expanding, that led to this idea that, gee, it must have all started at a point from which it expanded, and that leads to a family of conjectures called the Big Bang models. It's not one model, there's a half a dozen different versions of it. But the point is they try to codify what we think we know about the universe into mathematical form. It's basically variations of what we call the Big Bang. Well, it's interesting. This is all based on the idea the universe is expanding. How do we know it's expanding? Because of the red shift. Well, there's a couple of astronomers that have been focusing their lives on red shifts. Halton Arp from Germany, but also William A. Tift, University of Arizona, has spent more than 20 years collecting information on red shifts. He probably knows more about red shifts than we really want to know. But he's recently made a discovery that's got everybody disturbed. He's discovered that the red shifts are all a multiple of a common number. In other words, it's quantized. And the reason that's so disturbing is that implies it's not by some continuous process, it's by some digital process. Now, what's not obvious, but I happen to be in possession of an unpublished paper, should be shortly published by Barry Setterfield, who, taking that data, started to analyze it mathematically and has discovered that you can explain the quantization of the red shift of the stars on the presumption that light's been slowing down, because the light slows down, it changes the atomic behavior, and it would do that in discrete steps. And that could explain the red shift, interestingly enough. But again, those are just conjectures, and on it goes. Now, there are aspects of space we know are changing. The impedance of free space, about 377 ohms these days, has been changing, the refractive index, and on it goes. Radioactive dating is discredited for lots of other reasons than just this, but this certainly impacts it also. In getting into some of this, there's another aspect that we should talk about, and that's this area of entropy. Entropy is simply a mathematician's way of talking about randomness. Planck's constant is a product of entropy and the speed of light. As the speed of light slows down, entropy increases. And so it would seem that the introduction of entropy is relinked to the slowing down of the speed of light. Now, entropy is a strange concept, but it's very important for you and I to understand it if we're going to have any perception of what's really going on around us. In every field of science, we are moving towards randomness. It's intrinsic in our universe. And we observe it everywhere. Let me give you some practical examples. Your desktop at home, your closet in the front hall, your garage, your locker at school. You spend a Saturday and clean it all up, and it's all in order. Does it stay that way? As time goes on, as just random events occur, it tends to disorder, doesn't it? Now you may not realize it, but when you experience that, you notice that you have to devote conscious energy to keeping it orderly, or to make it orderly in the first place. Order requires outside input, always. And that's observed in every field of physics. It's observed in virtually every field of science. There's only one field of science that insists upon trying to deny it. And that's the field of science that deals with evolution. Because the theory of evolution requires a suspension of the entropy laws. Because the theory of evolution implies that somehow order happened on its own without the input of a designer. And that flies totally in the face of mathematically the mathematical universe. It doesn't make sense. I guess the real key idea is anytime you see order, it takes something, some outside input to make that happen. Let me give you the one exception that we observe to the a priori laws. We call it life. As we see life, we see disorder get into order. We see all kinds of examples where chemicals can get absorbed into a life form and order comes out of it. If we watch in a microscope a sperm fertilize an egg and we have a fertilized zygote, we have the first single cell of new life. As we watch it, the first thing that happens is mitosis takes place. It breaks into two identical cells, right? And then the two break into four. The four break into 8, and it continues. Identical cells, splitting directly. A cell breaks into two by a very orderly process, splits into two, and the one becomes two, and it keeps doubling all the way through, right? Except, if we keep watching it, we notice something else. As the embryo grows, we start to see sort of a line form down the middle. Then eventually it becomes a backbone. One end of it becomes a head, and we begin to see limbs form. We begin to discover that as these cells continue to divide, they start specializing. Some cells become different kinds of tissue. Skin, bone, muscle, cortical tissue, what have you, right? Finally forms into a totally complete person. It's interesting that that all starts from a code that's in the cell. We call it a DNA molecule. It carries the genetic history of that individual. It also carries all the codes from which the proteins are manufactured that create the tissues, and on it goes. Fantastic process. It's a digital code that's error correcting, and that totally destroys any possibility of it happening by accident, because it means it has a digital code implies a language preceding it. The language has to be designed, and the engine to implement the language has to be designed in parallel and in concert. Can't happen accidentally. An imperfection on either side disrupts the process. It's absurd to consider it anything other than the object of external design. But leaving that for the moment. The idea that the intricacies that make up your body, all those complex systems that are self-repairing and self-reproducing, in effect, are all a result of that DNA code, still doesn't explain it. Let's remember what I taught you about entropy a few moments ago. Let me give you an analogy to get across what I'm trying to suggest. Let's imagine that each person in this room was skilled at playing any musical instrument. Let's also imagine that each person in this room had at their disposal any instrument of choice. And let's assume I handed each one of you in the room a complete orchestration of a symphony. Would we have a symphony? I doubt it, huh? You see, what you need is somebody to orchestrate it. Someone to say that you're going to be bone tissue, you're going to be muscle, you're going to be cortical tissue, you're going to be a lung. You follow what I'm saying? The cells that are multiplying, who decides which one's going to do what? Who's going to... In computer design, this is called conflict resolution logic. There needs to be a procedure to resolve conflicts. And that's external to the entities themselves. What you discover if you analyze life mathematically, you discover that it requires, at each cell division, external input. The adequacy of the code within the cell ain't enough. The implication of that is God is involved in every detail. Isn't that wild? In Genesis, God pronounced everything He designed, everything that He made as good, that is free of defects by the Creator. So there's a very high degree of order that occurs in Genesis chapter 1 and 2. But then Adam falls. He commits sin, and from that sin we have the curse introduced. And I believe the speed of light started then. And that's not only the death of Adam, that's death itself. The basic structure of the universe was altered as a result of that curse, and is waiting for that curse to be relieved, according to Romans chapter 8. Now this leads to another concept that I think's important for us to grasp if we're going to deal with these terms and if we're going to try to really understand what's going on in the Bible. And that is a related concept of time. How many angles does a triangle have? How many degrees in a triangle if you had all the angles up? 180 degrees, right? 90, 45, 45, 180, or 90, 36. It's just speaking of right. Any triangle, you have all that plane geometry, you learn that the angles in the triangle add up to 180 degrees. So if you go outside with a transit and very carefully survey a large triangular piece of property, and you add up those angles and got more than 180 degrees, what would that tell you? Made a mistake. No. Assume you did it right. And yet you get a triangle that has more than 180 degrees. What do you know about that triangle? You're on a curved surface. Right on. It's an evidence of curvature. If you studied plane trigonometry in school. If you get into navigation, you study spherical trigonometry. And you discover that on the surface of the Earth, assuming for the moment the Earth's a perfect sphere, you can easily have triangles that have 90 degrees at each corner. 90 plus 90 plus 90. They're great circles. And that was the kind of insight that Einstein had when he's trying to solve some of the problems that led to his general theory of relativity. As he began to realize that space mathematically is curved, that we have more than just... See, plane geometry assumes only two dimensions. If you get certain mathematical behavior, in this case of the example I use, a triangle with more than 180 degrees, that is evidence of the existence of an additional dimension. It takes a third dimension to give you a sphere. No longer plane geometry, you're in a three-dimensional geometry. Well, that's what it was that insight that caused Einstein to recognize that we live in a four-dimensional space that has three spatial dimensions and time as a fourth dimension. And out of that came the general theory of relativity. And it was tragic that he didn't carry that same kind of modulus further, because he went to his death frustrated over the issue of gravity, trying to reconcile what we think we know about gravity to all the rest we know. If he'd gone to 5 dimensions, he would have come probably to Kluser-Klein supergravity models that are 5-dimensional models. And if you carry this through, as we try to in our little thing called Beyond Perception, you carry that through, that you eventually get to 10 dimensions, as we started this discussion with. But this dimension of time is an interesting dimension. Time is a strange dimension. See, if I have length or height or width, I can go in both directions, can I? I can go this way and back if I want. All these other dimensions are complete dimensions. They go in two directions. Time is a little strange. Some people call it a half a dimension, because you can only go in one direction on it, it would seem. Turns out not to be true, but that's basic experience. We can move forward and look back. We can't look forward or move back. Right? How many remember tomorrow? Anyone remember tomorrow? Yeah, I got a one-handed. You know, whenever I do that in California, I get nervous. But there are events that occur in physics that can be viewed as a time reversal. Feynman diagrams of certain particle behavior suggest time reversals, but it's not in our general experience. And one reason it's not comfortable to us, because a time reversal implies a logical contradiction. If I go back in time, in theory, I could murder my grandfather. And how would I ever have existed? You see, you get into these logical loops that don't make sense. And yet, of course, obviously, it's a very popular theme in literature. There's a lot of stories written on the premise of a time, being able to travel through time. All of us probably have encountered one version or another of H.G. Wells' The Time Machine is one of the famous examples of this. There was a marvelous movie called Somewhere in Time, or sort of a love story which exploits this idea of going back in time. Back to the Future, a recent series of tongue-in-cheek things. The Terminators, Terminator 1, Terminator 2 are stories that hang on this whole idea of time travel. Whenever I get into something like this, when I went back east, they wanted me to speak on this, but he says, if you're going to speak on it, you've got to tell them about Robert Heinlein's story. And so I'll just include this, because Robert Heinlein, one of probably the best known authors in the field of science fiction. I don't really know his motivations. I have to presume he decided he was going to write the ultimate convoluted time travel story. It goes about as far as you dare go in something like this. I'll give you a summary of it just for your own amusement. In Robert Heinlein's story, a baby girl is mysteriously dropped off at an orphanage in Cleveland in 1945. Keep track of this. Jane grows up lonely and dejected, not knowing who her parents are, until one day in 1963 she is strangely attracted to a drifter. She falls in love with him. But just when things are finally looking up for Jane, a series of disasters strike. She becomes pregnant by the drifter, who then disappears. Second, during her complicated delivery, doctors find that Jane has both sets of sex organs, and in order to save her life, they are forced to surgically convert her to a him. Finally, a mysterious stranger kidnaps her baby from the delivery room. Reeling from these disasters, rejected by society and scorned by fate, he becomes a drunkard and a drifter. Not only has Jane lost her parents and her lover, but he has lost his only child as well. Years later, in 1970, he stumbles into a lonely bar called Pop's Place and spills out his pathetic story to an elderly bartender. The sympathetic bartender offers the drifter a chance to avenge the stranger who left her pregnant and abandoned on the condition that he join the Time Travelers Corps. Both of them enter a time machine, and the bartender drops off the drifter in 1963. The drifter is strangely attracted to a young orphan woman who subsequently becomes pregnant. The bartender then goes forward 9 months, kidnaps the baby girl from the hospital, and drops off the baby at an orphanage back in 1945. Then the bartender drops off the thoroughly confused drifter in 1985 to enlist in the Time Travelers Corps. The drifter eventually gets his life together, becomes a respected and elderly member of the Time Travelers Corps, and then disguises himself as a bartender and has his most difficult mission. A date with destiny, meeting a certain drifter at Pop's Place in 1970. The question, of course, is who is Jane's mother, father, grandfather, grandmother, son, daughter, granddaughter, and grandson? The girl, the drifter, the bartender, of course, are all the same person. The paradoxes include Jane's twisted genealogy, being her own mother and father, and so forth. She's an entire family tree unto herself. Now, I have to believe Robert Heinlein, but about as far as you dare go with this kind of an idea. This sort of leads to an interesting quote. People like us who believe in physics know that the distinction between the past, the present, and the future is only a stubbornly persistent illusion. You know who said that? Dr. Albert Einstein. People like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion. Dr. Albert Einstein. I find it interesting that when Moses is before the burning bush, commissioned to go to Egypt, he says, "Who shall I say sent me?" And we get the name of God. The Ichyach Asher Ichyach, the I am that I am, transcends the verb of being. Past, present, future. He that is, who was, and who always shall be. The first to last. Interesting. Timeless. If we were spending time on this, more time than this, and you became concerned about whether you were going forward or backward in time, how could you tell? Most of the ways you think you could tell are wrong because the measurement is also in the same direction as you're going, like clocks or anything else. It turns out if you really analyze that, there's really only one way you can tell whether you're going forward or backward in time. It turns out the way you do it is to examine the entropy law. That's extent. The simple way to do that is to go home and get a deck of cards. And if you shuffle them and then lay them out in bridge order, you'd be uncomfortable, wouldn't you? Because your thing the more you shuffle it, the more random they get. But if you shuffle them and they became more orderly each time, you'd be disturbed. Why? Because you've entered the twilight zone. No. because you would be experiencing a time reversal. Because entropy is sometimes called the arrow of time. In the direction that we're going in time, we're going from order to disorder, from order to randomness, from design to chaos. We've poked at a few things like this. I think they're useful for lots of reasons. I've indulged this excursion for a couple of reasons. First of all, as we examine the field of physics, even with its precision and with at its very foundations, and we have good reason to treat it with a lot of respect at the one hand. On the other hand, we need to recognize that the field of physics, today especially, is undergoing major upheavals. A lot of this has to do with this possibility of the speed of light slowing down, which alters our whole conceptions in physics. Another thing has to do with the advent of quantum physics, particle physics, because the particle physicists have made some discoveries that are really disturbing. Particle physics is a world in which mutually contradictory statements both can be true. Particle physics is a world that now has discovered there is no such thing as local reality, that all particles in the universe are immediately intrinsically interconnected. And that doesn't make any sense at all, and yet millions of dollars spent have proven the Bell inequality and equivalent experiments to confirm there is no such thing as local reality. And that's not a subject we can summarize in a few minutes. I encourage you to get into that if you have a technical bent. We've done a thing called Beyond Perception that tries to make a beginning at that. Paul tells us this in his first epistle to Corinthians. The wisdom of this world is foolishness. And it's interesting how, on the one hand, we're dependent on it for our day-to-day understandings. On the one hand, at the same time, we need to approach all science with a great deal of humility and realize that that's just a glimpse of the real reality. Because we have the benefit of having in our laps the owner's manual, the guy that designed it in the first place. 66 books written by 40 authors over thousands of years that we now now demonstrates is an integrated message system that has its origin from outside the time domain itself, and thus authenticates itself as the Word of God. Another thing about physics, as we watch all this, you can't help but be impressed with the way things are continually changing. How many of you would take a course in physics if you found out they were using 1950 textbooks? Not many, because it's changing so fast. The Bible doesn't change, never has, doesn't need to, because it anticipates all this from the beginning. We start talking about light. It's interesting to see one of the 7 I am statements of Jesus Christ. He was the voice of the burning bush, as he announces in John 8. But he makes 7 I am statements that organize the Gospel of John. It's interesting that in John chapter 8, where he makes the statement that he is the light of the world, that may be far more than just an idiomatic use, as most people assume. It's interesting that that chapter also, the basic subject of that chapter is his origin, as he confronts the Pharisees who call him illegitimate, and he explains them a little more clearly just who he really is. John chapter 8. Central conflict in John 8 was his origin. But I'd like to close getting back to this quote by Dr. Einstein. People like us who believe in physics know that the distinction between the past, the present, and the future is only a stubbornly persistent illusion. Most of us, when we talk about eternity, tend to think of it as the advanced future. We have the future like tomorrow, next week, next year, and eternity is way down there somewhere. We tend to think of eternity as eternity future. If we explore the geometry of eternity, I have what I think is a more meaningful expression of the geometry of eternity. We're right in the middle of a line. If I take time as a line, we're in the middle of that. We call it now. Behind us is the past. It's nothing more than a memory. In front of us is the future. It's a hope. The past and the future are simply conceptual. You and I are forever in a place called now, the present, the immediate present. And if you want to talk about or think about or conceive eternity, I suggest you might better visualize it as a plane orthogonal to the line. not just 2 dimensions, multiple dimensions, but for purposes of rendering here, I've just rendered as 2 dimensions or additional to our own, but orthogonal to us where we are right now. Your connection with eternity is not in the future. Your connection with eternity is right now. The determination of your eternity is a function of what you're doing right now. The commitments you make to ensure your eternity are commitments you make right now. The real you is software, not hardware. You're temporarily resident in a temporary set of hardware. And we're all heading, hopefully, for an upgrade. The real you, call it soul, spirit, use whatever labels you like, is software, not hardware. It has no mass. Therefore, it's not physical. It's not limited to the constraints of time. It's eternal. The real question is where you will spend that eternity. The Bible tells us that all life will be resurrected, not just the believers. And resurrection is not an attractive idea to the unsaved. The destiny of spending eternity in the absence of the presence of God is something you and I cannot imagine. All kinds of biblical idioms are used, but they're just idioms. God prefers to have you spend your eternity with Him. That's why He created you in the first place. The problem is, to be in His presence, you have to be perfect. I won't ask for a show of hands. How many of you are perfect? Well, I'm as good as the next guy. Strike one. And I'm doing the best I can. Strike two. And so it goes. The good news is God anticipated this and has provided an eligibility for a destiny that you can't possibly earn. God has a destiny for you that's fantastic. And the eligibility for that destiny requires perfection, but He has provided Himself to be that perfection on your behalf. He did that through a love story written in blood on a wooden cross erected in Judea 2,000 years ago. Your opportunity to assure that destiny on your behalf is available for the asking, because He's done the whole job. In fact, insists upon doing the entire job. You can't add to it. That's blasphemy. And all you have to do is ask Him for it.